1, comma 2. Interval of increase. This graph is increasing on the left side of the graph. So everything from negative infinity to an x value of 1. So it increases from negative infinity until it hits 1. And then the rest of the graph goes down. So I know it's pointing down, but we're looking at the x values. So from an x value of 1 all the way until forever, this graph will be going down. So the interval of decrease is 1 to infinity. Excuse me. All right, this next example, let's go ahead and start with these and then we'll come back to factored form. Our domain, every time, all real numbers. Our range every time will be y is greater than or equal to or less than or equal to the maximum or minimum. So in this case, it looks like that's actually at about negative 0.25. But the important part is knowing that all of our y values are greater than or equal to that because they're above that point. And this point right here is negative 0.25. So every y value is that point or higher. X-intercepts, we have negative 3 and negative 2. So negative 3, comma 0 and negative 2, comma 0. Our y-intercept is up here at positive 6. And since it's our y-intercept, it's 0, comma 6. Notice every intercept will always have a 0. It just depends on if it's an x-intercept or y-intercept where the 0 goes. Our axis of symmetry, straight through the middle. And that's halfway between negative 2 and negative 3. So that's an x value of negative 2.5. And then our vertex, I go right here, which I know it's going to be the x of, from the axis of symmetry, so negative 2.5. And then I know the y value is going to be the same y value we used in our range, so negative 0.25. That's our vertex, and that's a minimum, right, because it's at the bottom. And then our interval of increase, this graph increases when it's on the right side of the axis of symmetry. So everything to the right of negative 2.5, if we are to the right of that, the graph is going up. So it's increasing from negative 2.5 forever. And then the interval of decrease, well, this graph is decreasing on the left side of the axis of symmetry. So everything from the beginning of the graph until it reaches negative 2.5. So the beginning of the graph is an x value of negative infinity until it gets to negative 2.5. To put this in factored form, right, going with the key points from today, I'm going to do f of x equals, or y equals, it's the same thing. My a value, well, the a was 1, so I don't need to put anything. And then x minus my first root, well, my root is negative 3, so minus negative 3 turns that to a plus 3. And then x minus my second root, well, that's also a negative, so minus a negative turns to positive 2. So the factored form for this graph is x plus 3 times x plus 2. All right, I believe this is our last set of problems for the day. Use the given information to write a function in factored form. Sketch a graph of each function and label the key points, including the vertex and the x and y intercepts. All right, the parabola opens up. Okay, so we know our a value is positive. The zeros are at 2 and 4. So I know I have an x-intercept at positive 2 and x-intercept at positive 4. So I can write this as f of x equals, doesn't tell me the a value, I just know it's positive, so I'm going to leave it as 1 for right now. And then if my 0 or my root or my intercept is at positive 2, I know my factored form will say minus 2. And then same thing with this one, if it's positive 4, I know it's going to say minus 4. And actually finding the vertex, I'm going to save that for a future lesson for when we do standard form. For where we're at today, I just want us to make sure we know that it's going to be the intercepts at 2 and 4, And if we want it to open upward, this is positive. So we'll get something like that. On the second example, we want the parabola to open downward. So we know that our function needs to have a negative in front. Doesn't matter what number comes after. If it's a negative number, it's going to open downward. If our zeros are at -3 and +1, that just means that that's where our roots or our x-intercepts are. But that also means that in our factored form, we're going to have the opposite of -3, so x plus 3, and we'll have the opposite of +1, x minus 1. Again, the vertex, we'll talk about that another time, but we know it's going to look something like that. All right, it's exciting stuff. Hope you guys are hanging in there. Keep working hard, do your best, and we'll see you back for some more factored form soon.